The Society concerns itself with fundamental principles and with problems facing the industry in such areas as legislation, economics, and education, as well as environmental concerns, labor relations, and health and safety. Representatives of the Society from time to time testify before legislative bodies and provide advice to federal agencies. The title of today's webinar is Water and Mining, Protecting and Sharing Water Resources. Right. It's presented by Patrick Williamson with an Intera, and I won't read his lengthy bio because it's in our promotional materials and also on the webinar. On the website. We will have ask you to write your questions in the chat, and Patrick will answer these questions after the webinar, after the presentation is completed. All our webinars are uploaded to YouTube and can be accessed through the MMSA.net website. The video of this webinar will be on the website within about a week. The MMSA webinars are supported by the Jacqueline Foundation. So Patrick, go ahead and share your screen and we will get started.
Good afternoon, everyone. This is a webinar being offered by the Mining and Metallurgical Society of America as part of our QP enhancement program. And then, as Betty mentioned, it will be recorded and posted to our website along with our previous webinars on a number of different topics. Topic is water and mining, protecting and sharing water resources. A little bit about me. Come on, there we go. Principal hydrogeochemist with Intera Incorporated. I have an office in Boulder, Colorado. I have a bachelor's from CC in Colorado Springs and a master's in environmental geochemistry from CU Boulder. I've been a consultant my entire career. I've been doing this for 36 years. I started out in environmental work doing Superfund, RCRA, CERCLA, landfills, nuke plants, rocket fabrication, a lot of solvent sites. And then I gradually started doing more and more mining. And so it's all I've been doing for the last 20 years is mining related environmental and hydrogeology projects, mostly development. I am a QP and a California registered geologist, very active in the MMSA, as well as the SME and the Acid Drainage Technology Initiative. I was the environmental division chair, and then later the 2014 SME conference chairman. And I have project experience in the US, Mexico, Nicaragua, Colombia, Chile, Peru, and Ecuador. Did a stint as the practice leader in Mexico for both Schlumberger Water Services and for SRK Consulting. Most of my work these days is still in Latin America. So let's talk about water. Water is a shared and recyclable but finite resource. It is considered a basic human right, and it is a fundamental ecosystem requirement. Water is also an essential component of all mining and metal, most mining and metal operations. It doesn't matter how big or wonderful your ore deposit is. If you don't have water, you can't develop it. You can't process minerals. So in the last decade or so, it has become widely recognized that a holistic approach to mine water management is required to maintain access to water resources during the life of a mine and to the ore. Global water resources under increasing pressure at this time with 1.2 billion people living in areas of water scarcity. Many experts predict that global water demand will exceed supply by about 40% as early as 2030. Another challenge with water-related issues with mining is preventing and minimizing environmental impacts. We suffer from a history of negative mining perceptions and a long history of mining impacts on communities and the environment that we have to overcome. All of these roll up into the topic of social license, which is convincing the communities that we are actually adding to the community and adding to the tax base, and we're a net benefit, because so many people, and I'll go into this in more detail, think of us as, you know, just polluters or water users or, you know, agents of chaos. So we have to build social license. All of these challenges require management and stewardship. That's going to be the topic of this, is how do we manage water in such a way that we're seen as good neighbors who are sharing a common resource, as opposed to, you know, international companies that come in and take water. So and so the concept of stewardship is the responsible oversight and protection of water as a resource that needs to be managed, shared, and preserved. So, and this is increasingly a difficult thing to do, because the water challenges are growing exponentially for a number of reasons, least of which is we're mining lower grade ore bodies with higher waste and stripping ratios. We're making more and smaller mines. More and more often, mining is being done in less developed countries that do not have either a strong mining tradition or a strong regulatory oversight. And then, as I mentioned, there's global water stress, particularly in places like northern Mexico, Peru, and Chile. So, you know, let's talk about where water occurs in mining. Basically, water touches all parts of a mine. The principal use of water is mineral processing. And so we've got water consumption in the entrained tailings, heap leach, and we lose water from mining operations due to evaporation from tailings and ponds. But water interacts with every part of the mine: the tailings, the pit walls, the mills, the roads. So we have contact water, and then we have produced water, which is the water that interacts with the reactive surfaces or the tailings or the rock. And there's different aspects of water in a mine. We've got groundwater flowing into pits or underground mines. We have inflows. We have contact water for precipitation. We have streams that run onto the site and run off the site. So there's this continuous spectrum of interactions of water with the mine. So a big part of the water stewardship is managing the local scale interaction of water with the mine infrastructure and minimizing those environmental impacts. We're starting with a problem with perception. When it comes to water quality, the mining industry has a long history of long-term environmental impacts, including depletion of water resources and contamination of water. Some Roman gold mining sites in Romania are still producing problematic acid mine drainage 2,000 years after the mining operation was started. You know, people have commented on the negative impacts of mining on water quality as far back as Agricola in De Re Metallica said the strongest argument of the detractors of mining is that fields are devastated by mining operation. When ores are washed, the water which has been used poisons the brooks and streams and either destroys the fish or drives them away. So a lot of people outside of the mining industry are convinced that these historic practices are still common. So the perception and reporting of historic impacts and recent accidents tends towards a certain degree of hyperbole and a poor technical understanding of the people that we have to build social license with. So, you know, here's some of my, these are pictures of just Colorado, this ground or mine impacted water in Colorado. And then we've got other issues. We've got illegal mining. A lot of people don't understand that modern industrial mining is not what you're seeing in the picture, which is illegal mining in South America with you know, clear visual and environmental impacts, as well as mercury use, contamination, criminal organizations, and child labor. We also doesn't help us when we have tailings dam failures. So the enormous improvements that we've made in environmental management are often overshadowed by a small number of accidental releases, which rightfully cause significant concern among those whose lives are affected. So, we've got Mount Polly, we have Marispriut in South Africa, and Samarco. So, hardly surprising, the perception and reporting of historic and current impacts and recent accidents leads to this sort of baseline where people don't understand what we do and how we can do it better. There are some good examples. This is a closure success, the Golden Cross in New Zealand. This was a mine that was active and had 600,000 ounces of gold, about 1.5 million ounces of silver, and operated from 91 to 98. And it was a complex closure. It had tailings pond, it had waste rock dump, it had underground workings, a cyanide processing plant. The rock was net acid generating. There were cyanide solutions, the TSF, that were being expressed during consolidation. It's a very wet climate, almost 3 meters of rain. And then but it can be done. So this is what the mine actually looked like at closure. And this is a success. So unfortunately, we don't get enough publicity for these successes. And not everyone is fully embracing the idea of the management processes or the stewardship processes that lead to these type of closure successes. So what are the risks? Well, for mining companies, poor water stewardship and management can result in financial exposure rising from delayed project approvals, constraints on production, environmental damage, and increased regulation. Poor water management and planning can lead to significant operational issues. I was involved with a project in Mexico where an incorrect groundwater model led to a 30% decrease in the throughput of the mill because they just did not have the water to process the ore. And it was due to an operational water issue. Beyond operational risks, poor water management can lead to loss of investment attractiveness, a decrease in shareholder value, and problems with access to other resources, such as the ore and the land that you need to occupy to do it. So poor water stewardship can cause concern for local communities and other water users, and that concern can damage business reputation and erode the social license. So Ernst & Young puts out this wonderful diagram every year. And so for the last 5 years, issues related to social license and environmental have been some of the principal concerns for the mining industry. This last year, 2022, environmental and social was number 1. License to operate was number 3. License to operate is linked to water stewardship and water use and sharing water resources. In 2019, 2020, and 2021, the number 1 concern was this license to operate, which is, again, part of that is related to water. And I know firsthand about the investors' concern about these water-related risks. In 2017, at the Columbia Gold Symposium, I got cornered by Rick Rule from Sprott to ask me about environmental issues. And his concern was that as investors, they were having the most problem evaluating risk around the issues of water quality and water supply, because they're kind of soft numbers related to social issues. And a lot of companies weren't spending nearly as much on those aspects of risk mitigation as they were on just making sure their reserves were robustly characterized. So what are the specific water and environmental risks? Well, as I said, water is a shared asset. About 70% of mining operations from 6 of the largest global companies are located already in water-stressed countries. So they're trying to share water and they're using a lot of it. Water can be expensive. It can be 10 or 15% of the capital expenses. So increased attention by NGOs and investors on water resources and best practices, they're expensive, but they're the best way for us to defend ourselves against certain resistance against mining. So water quality doesn't exchange, the water issues, water management, aren't just supply, they're also related to water quality, which is related to waste rock management. This is a picture of Tia Maria several years ago where the locals were fighting Southern Peru copper, which is a Grupo Mexico property. Recent activities at Conga and Tia Maria have shown that concerns over water combined with a poor history of water stewardship and a lack of social license can delay or kill a project and really add to the expense and the time to bring a project into production. Social media. Citizens have tools now that they didn't have 10, 15, 20 years ago. Instant messaging, internet, the communication is so much better for these groups that are organizing against mines that, we have if we don't manage social license, well, you end up with a formidable bunch of people who are well organized against the mine. Mining isn't the only activity that impacts water quality. Colombia's got a big issue with water, despite the fact, in some areas, despite the fact that in a lot of the country it gets a lot of rain. The problem is they don't use groundwater. They don't have a very well-developed infrastructure for treating and storing water. So even though there's abundant surface water, there's actually a shortage of potable water. And when a mine comes in and says, we're going to use some of that, that creates problems. Baseline, short-term data collection periods. This is a big environmental risk that I see frequently. Mines don't understand that you need several years to establish a robust baseline. And the baseline is what's going to be the basis for your water management strategies and objectives. You need enough time to do it right. Weak regulations, companies taking advantage of weak regulations or poorly implemented environmental regulations, water management regulations in developing countries. It's a short-term strategy by taking advantage of these regulations that leaves long-term environmental legacies and continues to damage the environmental reputation of the mining companies. And then climate change. This is a big issue. It's hard to quantify, and it's definitely happening. I've seen the data. Intera works with climate change planning. It's a big issue because you have to guess ahead to what the climate changes might be in 20 years. Risks associated with mine water and operation. This is a figure from the Water Stewardship Manual by the Government of Australia, Leading Practice Sustainable Development Program for Mining Industry. This is an excellent series of books in English and Spanish. They're free, and they're an excellent reference manual. And this is I like this figure because it illustrates the operational risks associated with water and water stewardship across a company. And so what you have is, at the corporate level, you have people devising frameworks and drivers. They're looking for water management strategies as part of a business strategy. And then that information gets propagated down through the organization to the lower boxes, which are operational water management and monitoring. And the dissonance that we've got here is that the people at corporate either aren't communicating or can't enforce the corporate ideas, ideals, and philosophy at the unit level. And so you end up with people promoting a water stewardship while the people at the mine site are just trying to get things done on a day-to-day basis. They've got their noses stuck in the tree of, do I have enough bottles for the next monitoring round, as opposed to a bigger picture of what is our long-term water management strategy and how are we implementing it? And so the whole bit about, and then there's the issue of short-term goals versus long-term plans. So many times the people that are running operations that include water management, they're thinking from week to week, month to month, or trimester, semester to semester, for how many ounces they're going to produce, and they don't think long term about water management. And so you end up with this cultural dissonance between corporate and operations, between short term and long term. Another operational risk that happens a lot that's related to water is deferred investment and closure. There are all of these best practices about developing robust closure plans, bonding them, upgrading them. They don't always happen in mines, and you end up, and I've seen this several times in Mexico, literally closing a mine and then saying, how are we going to close the pit? Where the infrastructure and the staff are gone. And the company calls up and says, hey, this pit's got really bad quality. What do we do about it? I've already talked about national regulations in developing countries versus best practices. And then internal water governance, which is how are we going to do it from the corporate level down to the mine level? Community factors also present a risk with unrealistic community, poor communication and unrealistic community or government expectations about what water is going to be released and the quality of that water or what impact it's going to have. Lack of community involvement, where the community is not integrated into the solutions for water management, which leads to a lack of social license, a lack of trust and social license. So where is this all taking us? Well, in the last, I'll say 10 years, 7.5 years, the industry, the responsible mining companies and the associations that they belong to have been developing a new philosophy and vocabulary, and it's really centered around water and optimization and baseline studies and understanding the site conditions better and managing them better over time. And there's a new vocabulary about water risk, water stress, virtual water, water footprint, and the concept of mining to closure, all designed to minimize environmental impacts, water consumption, socioeconomic impacts, and environmental risk. And this comes to the concept of stewardship. Stewardship is defined as the responsibility to protect, enhance, and preserve assets that do not belong to you, but have been temporarily entrusted to your keeping. The Alliance for Water Stewardship has another where they talk about socially equitable, environmentally sustainable, and economically beneficial with stakeholder inclusive processes and catchment-based actions. I'll be using that catchment-based a lot in the near future. It's sort of a difference from we're only going to look what's around our mine and our wells. You have to look at the entire basin. You can't look at just your immediate area. And then the International Council on Mining and Metals has a water stewardship framework. It's online, it's excellent. And they've got 3 sort of precepts. Engage proactively and inclusively. That's reaching out to the communities, establishing social license, and being proactive in how you develop the information to manage the water resources over the life of time. Again, adopt a catchment-based approach, not a local, and develop and implement effective water resource management tools. So let's talk about those in a bit more. This is borrowed from Agnico Eagle's water management policy. They have an excellent set of guidance documents that I've been lucky enough to work with. So the first precept is risk assessment and management. And risk assessment is really understanding what you're getting into and understanding where risks might arise. And so the best way to manage risk is to have a really good baseline. So you have to collect baseline data for all your watersheds that might be potentially impacted by the operations, either by disposal of water, removing water, discharging effluent, and then having a very clear understanding of the background conditions, water users, water usage, and the social and cultural aspects of water. And the baseline, it is the most, I'm sorry, I'm showing my bias. It is the most important set of data that you're going to collect, maybe aside from the mineral reserves, because you can only do it once. And if you don't do it right, you have no remedy. And it is the foundation for comparison for all the impacts that you're going to have to remediate or manage. And so if somebody challenges you legally and says you're contaminating the stream, if you don't have bulletproof baseline data showing that that was what it was before, or no, we're not doing that, you have no remedy. So the baseline is just absolutely critical as a way of establishing the a priori conditions and defending the mining operation against accusations. You also have to identify your stakeholders. Who are the stakeholders involved with water management? Who are the other water users? And stakeholders might not be communities or people. They might be ecosystems. They might be fisheries. Establish the water management objectives. So what are the operations that are going to require infrastructure to meet the objectives? What are the installations? What are we designing them for? To meet compliance requirements? Do we have a contingency in case one of them stops working? And what are the use objectives? Is it to reduce freshwater use? Is it to remain in compliance at all times? Is it to meet regulatory limits for discharges and withdrawals? And then a third important concept is governance. So it's, governance for operations. Who's going to do what? What are the specific roles and their responsibilities for managing the water and water quality? What kind of people do you need? What kind of training do they need? What kind of reporting are you going to produce? What is the accountability from corporate down to the techs who are collecting water levels? And so that governance includes the entire structure of the on-site operations, and it also extends into the infrastructure. What are the best available technologies and applicable practices that you're going to implement? What kind of infrastructure are you going to have to manage water? We'll talk about some of the tools in a little bit. And it's, applying risk-based approaches to manage risks associated with the infrastructure, and then having the planning to put them in on time, have contingency capacity, and operate them right. So, I'm going to spend a lot of time in baseline components because it's one of the best ways to manage risk. And this is, the technical process required to address environmental characterization by, it requires good science across a range of disciplines. And the water-related ones I've highlighted in red: geochemistry from the waste rock, hydrogeology, groundwater, surface water, sediments, water quality, surface water quality, meteorology, and sort of a secondary social impacts. So a big chunk of what a baseline study involves is centered around water or has water components in it. So what are the things we ask? Well, what is the site hydrogeology? What's the depth of groundwater? What's the direction of flow? What are the aquifer characteristics, usage, structural controls on it? What is the baseline water quality and flow? What is the water balance, the catchment water volumes and quality over time? And your classic storm and flow IDF, intensity, duration, frequency calculations. Where are you going to get the water for the mine? This is, I did a project in Oaxaca for Minera Cuscatlan, where the challenge was we could get groundwater, but the Zapotec communities that we were working with didn't understand the concept of a water right, because water was a communal good in that society. And the idea of somebody owning water that they considered to be a communal good was a big, it wasn't going to work. And so we looked around at an alternative for groundwater for the mill and ended up approaching the city of Ocotlan de Morelos and taking their treated wastewater. We put the mine put some money in to bring the water treatment plant back into operation, and built a pipeline. So the local community isn't seeing the mine using groundwater, and Ocotlan gets the benefit of the financial backing to keep their water treatment plant operating well. So we need to look at what water resources might be affected. And then there's the aspects of the mine operation. What are the geochemical characteristics of the waste? What is the mining and processing method, which is very much dictates how the waste is going to behave over time? That's the topic I just mentioned. Where are we going to discharge? At what concentrations? When and where? What possible impacts will the mine operation have on water resources? And then the whole concept of toxicology. The National Licensing Agency in Colombia, ANLA, is going down in this direction. It's no longer enough just to meet discharge requirements. They're going towards a biological risk assessment approach for discharges, looking at both human and ecosystem ecotoxicity. So what are the tools? We go out and we collect all this baseline data. We've got a database and we have an understanding. So I misspelled synthesis, but these data need to be integrated into, synthesized into an understanding of water and chemistry for the site over time. We need to develop site-specific and regional climate and hydrologic models. What is going to be the flow? What's going to be the rain flow? Where is it going to go? Where is it going to contact the mine? How is the mine going to affect these streams and surface water bodies and runoff? You need to have a conceptual and then a numerical groundwater model to manage it, especially if you're dewatering or even using groundwater as a water supply. You have to have a water balance. You have to understand where water is coming from, how it's circulating, where you're losing it. And you have to have water quality models, simulating how water chemistry changes as it circulates around the mine and then goes through treatment to discharge. And you have to understand the chemistry of the waste. What if you put in a waste dump and you don't cover it right away? What's going to come out of it and when? Because you're going to have to manage or treat that. If you don't know, it will appear when you least expect it and are prepared for it if you don't prepare for it. And then there's additional tools. There are tools that can be used to support the project in managing water quality. So you have to have monitoring programs. You have to monitor flow in streams, in pipes. You have to monitor the water quality. You have to have an operational waste rock management plan. And that should be part of a closure plan, which is designed in the PEA, refined in the PFS, refined in the FS, and then updated every couple of years, and if possible, implemented, gradually rather than waiting until the end. You have to have a closure plan, and it has to be stress tested. It has to be evaluated. I've been working with some closure plans recently where somebody made a suggestion for managing waste rock that was never tested but implemented, and it's not working. So that's a problem. Quality assurance project plan. This is an overarching philosophy and document that addresses everything related to generating representative data, such as how to collect a sample, how to analyze it, what QA/QC measures should be associated with it, how to review it. Something as simple as charting the water levels in a piezometer and looking at them to see if they're accurate or if there was a measurement error by the techs in the field. So, and then data management. I am constantly amazed at what happens between all of the high quality studies to develop a mine and build it. And then there's this process where we go into construction, and then, the environmental consultants aren't as involved, if at all. And then we go into operation, and the mine hires their own staff. And in that transition period, data get lost and mislabeled, and people say, well, I've got the Excel spreadsheets from the original consultant. Well, I'm sorry, Excel is not a database. So data management is a way to protect yourself because you don't lose the data. Make sure that the data are representative and that monitoring continues during that transition from the feasibility studies into operation, and just is a much more efficient way to generate your reports, look at your data, and manage the risk associated with water. So, what are we supposed to do? Miners have to act as water stewards, and that really depends on good science and adequate characterization. We need to implement industry best practices and not what we can get away with in some countries due to poorly written regulations. We need to engage stakeholders in an open and transparent manner so that they understand what's going on and hopefully embrace the economic benefit of a local mine, because they're not concerned about the water because that's being managed well. You have to identify and engage the people and groups that may influence or be impacted by operations. You have to understand community access requirements and concerns related to water. You have to collaborate and partner with them to mitigate some of these shared risks, or shared impacts, and ensure understanding within the workforce of water issues and actions. You have to understand the social, cultural, economic, and environmental value of water. I already mentioned, one indigenous community that has a different perspective of water ownership than the Mexican government. That's something that needs to be worked with. The effective water resource management, which that's catchment governance processes and requirements, the baseline, identifying and understanding high value water assets so that they can be protected, what are the existing and future water users and trends? What are the long-term and cumulative impacts of mining operations? And developing site-level water management plans that manage water stewardship, manage risks, and safeguard high-value water assets. And you have to plan ahead. It's just, water is not one of these things that you can retroactively go back and take samples of, take measurements of, or you know, if you're relying on a water source, frequently you have to think several years ahead. To, if you're developing a new water source for a mine, you have to do geophysics, you have to do drilling, you have to do test wells, you have to write and test groundwater models, you have to put in infrastructure. You know, some of these water supply infrastructures take years to develop and bring online for a mine. And that's all I have to say. So ultimately, it's our responsibility to create a new paradigm of environmental and water stewardship for industrial mining. Failure to do so is just going to make it harder to obtain the funding, social license, and access required to develop new projects and efficiently close current operations.
Well, thanks, Patrick. That was very interesting. We appreciate your time. I don't have very much in the chat. Fernando has a couple of comments. He says water management and mining should have a focus in basin. And you did cover that. And he also says in many mining operations, we have a political issue. Do you want to make comments on any of those?
I'm sorry, I didn't catch the first part of it.
The first part was, he says water management and mining should have a focus in basin, BASIN.
Yeah, that's the catchment level. That's
and
the
you
catchment
mentioned
level
that.
approach. Yes.
Yeah.
So yes, it absolutely is needed. We have to look at you have to look at the entire basin, because you know, groundwater is a basin-wide phenomenon. You have to look at, you can't just look at what the cone of, you know, the cone of depression around your pumping wells. You have to look at, you know, whose alfalfa field are you going to kill?
Okay, and then he also talks about mining operations, that a lot of mining operations have political issues, which we're generally pretty familiar with.
Yeah, political issues, those are related to social license. You know, if you do good science and somebody's accusing you of having an impact, the answer, you know, and a non-political answer is you have to have the data show them that they're wrong.
We have a comment from Scott Jalkover. Says, well done, really enjoyed it. And we have a comment from Jason Penza. For the groundwater models, maybe focus also on aquifer response itself, not on water balance per se. Be careful of groundwater budget myth, ?
Yeah, I mean, groundwater modeling is not just measuring the aquifer response. It's understanding the physical parameters that control flow and storage and the amount of water that's coming in and out of them. And part of a groundwater model or in a mine is the water budget, which is managed or documented through the water balance. You know, I'm a huge fan of GoldSim, where, you know, you're looking at not just with the water that is coming in, you know, circulating. You can piggyback water quality on GoldSim, you know, and a water balance is required to get a cyanide code. You know, you have to have a water balance to get that.
Alistair Horn says, great talk. Can you speak more about demand outstripping supply by 40% by 2030?
Oh, no, I just found that on a article that I read. I'd have to look up the reference.
Okay. Fernando says, thanks, Patrick, for your presentation and comments. And Steve has a question. Is pit backfilling a preferred alternative for ESG, or does it depend on the mine's location?
Yes, to both questions. And I actually helped get the first mine pit backfill permit in Mexico, so I do know something about the topic. For some reason in the United States, the fear of, quote, sterilizing the resource, not being able to go back into a pit after mining is concluded, has greatly outweighed the cost and ecological, environmental benefits of pit backfilling, which is much more widely used in Canada and Australia. If you look at the literature for pit backfilling, most of it is out of Canada and Australia. And under certain, you have the combination of circumstances have to be right. But if you look at the geochemistry of the pit and the water, groundwater that goes in there, putting tailings into a pit is a wonderful way to get rid of them. That's not the right way to say it. It's a wonderful way to store them safely, because once they're consolidated, they tend to get, they have usually much lower flow characteristics than the surrounding rock, especially if a fracture system. And so water doesn't tend to go through them, it tends to sort of go around them. If you have to keep them submerged, if they're particularly reactive, it's easier to keep a layer of water on top of tailings in a pit than it is into other type of surface water bodies. I'm a big fan of both pit backfill and mixed rock tailings facilities.
All right. Tim Arnold thinks you did a great job, Patrick.
Thanks, Tim.
And Alistair has another question. He says, you mentioned virtual water. What is that?
Virtual water is the water that is required to produce a product that you don't really see as part of the product. So here's a concept. When we buy wheat, there is a virtual water component. How many gallons of water did it take in Ukraine to grow that? You can put a virtual water cost on any manufactured product, be it gold or beef or honey. It's the water that was used in some other location that we didn't really account for or pay for, and we're sort of, and is inherent in the product. So in the United States, we have the proximity to Mexico to benefit from all the vegetables that are grown in Guanajuato or some of the northern states. But we're not paying the price of the virtual water for those severely overexploited aquifers. So that's what virtual water is. A very interesting concept.
Jesus Velador says, thank you, Patrick. Very relevant topic, particularly with the recent changes to the mining law in Mexico.
Yeah, I'm very curious to see how this is all going to play out, because I think that, I was very concerned about some of the preliminary changes I saw in the Mexican mining law, particularly the 5-year renewal for the water permit, which apparently was removed. I commented on that. But, I'll be honest, when I make the comment about weak environmental regulations for mining, I'm talking Mexico. Mexico's environmental regulations for mine waste are very poor. They're nowhere close to best practices. You can, and I've seen this, I've stated this to clients over and over again, you can do what the regulations require and still have a very significant risk of acid drainage over time because of the way that those regulations are written.
All right, that's all the comments that we have in the chat. Anyone who's on is welcome to raise their hand and ask any questions they might have verbally. Oh, Dietmar Dietering has a question. So,
Hi, thank you so much for this presentation. I know there's a growing awareness of the challenges of solar evaporation for lithium extraction. Could you talk a little bit about that, kind of tons of water per ton of lithium, or some metrics that would help kind of determine the impacts thereof?
No, I cannot speak to lithium. Lithium is something that I I don't work in the lithium sphere. So I'm sorry.
good question, though.
Yeah, good question. I'm not the right person to ask the question.
Oh. Okay, anybody else? Okay, well, thanks everybody for showing up. We really appreciate your participation, and just watch for our, I'll send out an email when the video is posted to the website. And Scott Phillips, thank you for your appreciation of Patrick's comments.
Thank you, everybody.